when methyl benzene, also known as toluene, CH3, CH3, it reacts with bromine Br2. These are same reagent Br2 in two different ways. First one, if you take the H nu sunlight. Second case, we can take the presence of Lewis acid FeBr3. This is called as in the presence of light. Light opposite is the dark. Sometimes they mention dark or not, no problem. Dark. So if you take the bromine in the presence of sunlight, homolytic cleavage takes place. So here radical. Now in this case also homolytic cleavage in toluene. So Toulene reaction, in the presence of free radical, this bond breaks homolytically. Hydrogen radical and this is carbon radical. But in the presence of Lewis acid, para position hydrogen substituted as electro H plus, because here electrophile is formed, here radical is formed. What is the reason between in presence of Lewis acid this hydrogen substituted, in the presence of light this hydrogen only substituted? Main reason is in the presence of radical, here toluene, when toluene if radical bromine radical comes at, here electron density is present. Electron density means negative. Here also electron negative repulsion. In between these two, repulsion. Therefore, this bromine radical not attached to benzene ring. First reason repulsion. Here I will give the second reason. Second reason is, in case of toluene, CH3, methyl benzene, if this bond breaks homolytically, hydrogen radical, carbon radical, it gives rise to the stable benzyl radical. This benzyl radical is more stable due to resonance. This radical is stable due to RS. RS means resonance. If, third point here, if benzene nucleus hydrogen, and benzene ring attached hydrogen breaks homolytically, so it gives rise to one radical. It gives rise to this type of radical. So this radical is not stable. No resonance. No resonance means what? It is a not stable. Not stable. So what is the main important one point? One point is, see that in the organic chemistry, in anywhere, generally more stable radicals are formed. Radicals are formed. So here what is main important point? See this. In presence of sunlight, in case of toluene, due to breakage of this bond only, already we know that bromine in the presence of light H nu. This is the reaction condition. In presence of sunlight, we know that homolytic cleavage, there is no electrophile. So after breakage of this one CH benzylic hydrogen radical, we got this type of radical. See these two hydrogens as it is radical. This radical is stable radical. Stable radical. Radical intermediate this is a. So generally in the organic chemistry, stable radical intermediates are formed. Preferable. Stable radicals are preferable in the organic chemistry. So after formation of this radical, we know that here hydrogen radical, one bromine radical attaches here, HBr is eliminated. Then one bromine radical is there. For example, this hydrogen bromine X, this bromine Y. So this bromine X bromine attached to this hydrogen, X bromine attached to this hydrogen. So HBr X, this HBr eliminated, and Y bromine radical is present. That Y bromine radical gets attached to here. Another radical attached to C, two hydrogens, no change. See that these two hydrogens as it is. Then this Y bromine radical attached to carbon radical. So bromine, this is a Y bromine. So this is called as the one free radical substituted by the another free radical. Hydrogen free radical substituted by bromine free radical. So it is free radical substitution. Free radical substitution takes place. Next it's a counter, and means instead of light, if you take this any electrophile CH3 Br2 in the presence of FeBr3. FeBr3 means Lewis acid. So in this case what happens? Br minus Br plus. This Lewis acid taken by this anion because it has empty orbital. So what is remaining? Br plus is remaining. And the benzene ring, Toulene and CH3. Then remaining is the Br plus. Here Br plus this pi electron, 6 electron density attraction. So this electrophile attracted by benzene nucleus, not attracted by the side chain. So Br plus attacks at benzene nucleus. And the CH3 group is the ortho para directing group. So we discuss why it is ortho para directing group in next video. But here in this one what happens is the para position hydrogen H plus substituted by the bromine plus. And why here substitution only takes place? That is also one of the main important explanation. Reason we required. In case of substitution only, this benzene ring not loses its aromatic character. So this is aromatic. Aromatic character retains. And aromatic character play a very important role to decide the stability. And organic molecules are most of the cases they prefer exist in the stable form only. This is the reason why bromine plus substituted by the H plus electrophile only. So it is the electrophilic substitution reaction. And this is the free radical substitution reaction. Free radical substitution reaction. There is a difference between these two reactions.